moving on to our next presentation, we will be having John Kehrli from Qualcomm, where he's a senior director in product management. He's been focusing on cloud edge AI products and driving the strategy there around product management for the chipsets and the software, as well as benchmarking and roadmaps. So he'll be talking about Qualcomm's Cloud AI 100 product, and his presentation is on high performance, power efficient AI inference acceleration. John?
All right, let's get started. Hey, so thank you so much for that kind of introduction. So as Linley noted, John Kehrli here at Qualcomm. I lead the product team in the Cloud Edge AI organization, responsible for hardware, software, and benchmarking and other areas as well. First and foremost, I'm honored to be here today at the Linley conference to share some exciting updates on our Cloud AI 100 solution in particular, including some recently announced MLPerf results. So hopefully some folks saw that this week. If I'm not mistaken, I think I'm the last one, so I appreciate you guys staying around for the last one and tuning in. And I know my time is short, so let's kind of get into it. Since April of 2019, that's actually, believe it or not, 2 years ago, when we first announced the Cloud AI 100, we spoke about bringing leading performance per watt to the cloud, talking about our attention to the space, leveraging our design expertise and mobile heritage, including low power consumption, signal processing expertise, and scale. And since that time, we've executed on that vision, and with some tangible results I'll talk about today. And to kick things off, I'll kind of quickly talk about the industry before we dive into it. So I'll go quick over these kind of upfront slides, but this gives you an idea why we're very excited about this space. So external analysts are forecasting explosive growth, especially in the AI inference market, which is the area in particular that we're focusing on right now, with the Cloud AI 100 being an AI inference accelerator. And we're seeing this, on the front lines. We're working with a number of customers, and we're seeing this explosive growth as well. This report comes from Omnida last year that shows explosive growth in AI, especially in inference side, which is dominating the market per their forecast. And we're only seeing this continue to grow each and every year. Very, very strong CAGRs. If this table is looking at a high level, but if you kind of peel this back and you look at their report, you'll notice they kind of break out kind of low, medium, high being 50 tops and above, being really where the explosive growth is coming from. And that's really where the Cloud AI 100 really shines and is targeted. Okay, so next slide. So here at Qualcomm, we have a long heritage of AI research and development, with well over a decade, I think 13, 14 years at least, of focused research and development and products and commercial deployments. In the markets Cloud AI 100 targets, we're seeing a number of exciting use cases and opportunities. The common thread that binds each of these together is really around best-in-class performance per watt, lowest latency, which really energizes us here at Qualcomm. We're excited about this. This slide shows you an example of 3 key areas we're focused on, although there are many others as well. So I'll touch upon these very quickly. On the data center or the cloud side, this space really targets inference applications with leading hyperscaler companies that require heavy compute, things like natural language processing, recommendation networks, prediction engines, those type of things. Things like recommendation networks really help provide more personalized experience, could be shopping or otherwise, but we're seeing a lot of interest there as well. 5G edge box, everyone's kind of got their own term for this, intelligent edge or whatever it might be. But this is an area we're very excited about. It's a rapidly developing area. I've spoken about this in the past in different forums. We actually, even here at Qualcomm, launched our own development kit, our AI Edge development kit for this in this area, that not only leverages AI, but also some of our leadership in 5G and AP processing as well. This can be deployed anything from smart cities, retail, safety, traffic management, a number of other applications as well. And the last one here, 5G infra. This is RAN infrastructure, equipment, base stations, those type of things. And the consistent theme or consistent requirement, that we're hearing here is, really offloading traditionally, intensive computational intensive algorithms and calculations to neural networks. So those are three areas we're seeing. So you're probably thinking, okay, John, right? I get it, but prove it to me, right? We announced the Cloud AI 100 back in 2019. 2 years ago, I spoke about it more last year, shared more information, and you're probably saying, okay, how do you stack up? And really, I'm glad that you asked, because this is really a response to folks like Linley that really asked me back in August and September last year to submit more for MLPerf. And so we did submit for MLPerf on the Cloud AI 100 accelerator. This is our first submission into MLPerf. And this slide's going to talk a little bit about that submission and how do we stack up. On our side, really what I did is I focused on more than one models. We have 2 models in particular that we focused on, both ResNet 50 and a large tensor SSD ResNet 34. We not only submitted the 2 models, but we also submitted multiple form factors as well. We submitted an edge form factor, which is our AEDK. We also submitted a data center form factor as well. So I wanted to kind of give you we made a large base here, multiple models, multiple form factors. Before we jump into the ResNet 50, so this is ResNet 50, which is obviously a convolutional neural network focused on image classification. I want to kind of calibrate how to read this slide and some of the important finer details on this. The performance here is from MLPerf, which was just released on Wednesday. So this data is very, very fresh. As most people know, MLPerf is now looking at power, which is music to our ears here at Qualcomm. Looking at performance per watt is very important. And however, power submission was just started with 1.0 and not required by all folks. You don't have to submit a power submission. So in this case, some of the competitive solutions that we stack up against, we use publicly released, card TDP numbers that they've announced, in particular A10 and A30 from our friends at NVIDIA. So we use that on the data center side, on the left-hand side of this chart. On the right-hand side of the chart, where we look at edge, those are more system-level powers, and those are 100% aligned to the MLPerf numbers here. So the way to read this on your x-axis, as you move from left to right, the power goes down. And then on your y-axis, you have really offline performance, which is really peak performance. We included the solutions in the industry. Some really strong solutions have been in the market for a while. T4, as well as some recently announced solutions as well, the A10 and the A30. I was not able to include others like the A100 or the A40, which are more in the 250, 300 watt range, card TDP range. That kind of fell outside the scale. So by the way, this is all you calibrate, int 8, batch size 8, that type of thing for this particular one. So as you look at this, as I've been kind of trying to calibrate, I'm sure everyone's been focused on the data, which is great. A couple key things that I'd like to kind of call out, right? If I look just really quickly at my x-axis and kind of look at around the 70, 75 watt range, you'll see the NVIDIA T4, and you also see the Cloud AI 100 PCIe. And I'll talk about that form factor coming up. That's a traditional half-height, half-length form factor. But really what you see is that equivalent power. We are 4x the performance today for ResNet 50. Again, merchant silicon solutions today for AI inference accelerators. And then against recently announced A30 or A10 with roughly twice the power. That's about twice the power. It's 150, 165 watt range. We are still the highest performing solution. So really, performance per watt is a key metric that we focus on and our customers focus on as well. Shifting a little bit to the right on the edge side, again, we kind of call this less than 50 watts. And again, this is 100% aligned to the system level power numbers that were in MLPerf 1.0. You can see even with the total system power that we have here for our dual M.2 form factor, it's still better performing than a T4 at the card form factor or card power level. And against similar solutions at a system power level as Xavier or whatnot, we are roughly 4 to 5x the performance. It's also important to note, obviously, I don't have a lot of time to talk today, but feel free to look at the MLPerf results. Also look at latency. I think latency is very important and something I won't get into time to talk about today. But we also see this being a very important factor, especially for the edge markets. And our MLPerf latency was also something to take note of, and we're very, very proud of. Okay. Next slide. So now I'm going to transition to a large tensor at SSD ResNet 34, which is based off a COCO data set, as we know. Similar to ResNet 50, so all the same kind of rules apply, your X and Y axis and whatnot. Similar to ResNet 50, when you start on the left-hand side, again, on the data center side, you can see our PCIe solution is roughly about 2.5x higher performing than the T4 today at the same card power level. And our solution outperforms a recently announced A10, which is twice the power of our PCIe card today. And we are slightly behind the A30, which is more than twice the power. So from a ResNet 34 SSD perspective. Obviously, this doesn't include things like batch size, which I think is important. So for us, we submitted a batch size at 8. Some of the other solutions use much higher batch sizes, including batch sizes of 32, which could have helped drive different performance results as well. On the edge side, our dual M.2 and what I call dual M.2 edge, and I'll get into that again in the following slide. We are a fraction of the power of the T4, and still having higher performance as well. Even comparing again system power on the edge versus card power on the data center. And our overall edge solution again here demonstrates best-in-class performance for this network as well. So these are just two examples, again, edge and data center, different models, but from our perspective, in a world where total cost of ownership really matters, it's a very compelling story to drive a lot of interest in what we're doing here as well. And driving performance per watt is in our DNA here at Qualcomm. And we continue to look forward to submitting more models, more platforms moving forward with MLPerf in the August submission for their 1.1. So we're excited to continue this and share more results as we move through this year and beyond. So I mentioned a couple different card types. I think this is something to really kind of make sure that we align on. We really have 3 different card types for our Cloud AI 100 accelerator cards. We have our more, moving left to right on this slide, we have our more traditional half height, half length, 75 watt solution, targeted mostly to hyperscaler markets. And then we also have 2 different dual M.2 cards that align to the OCP, Open Compute, that might be better suited for on-premise edge applications or else. We configure each of these solutions with different DRAM our customers are requesting. And our middle solution there, if you look at it, our dual M.2, that's our highest performing TOPS per watt solution in the market. All of these are sampling today. All of these have sampled for approximately a year. And so we do expect commercial deployments off of each of these. Just to kind of hit a few common themes on each of these solutions. So we have a very high on-chip SRAM, 9 megabyte per AI hardware block, which really allows us not to go out to LPDDR as much, even though we do use LPDDR4X here in this case. Using LPDDR4X helps us drive higher performance per watt and lower costs for our customers rather than HBM or other solutions as well. So it's a good solution. We're seeing a lot of models run on the SRAM and not having to go out to DRAM, especially on the edge side. We do have higher memory bandwidth when needed. And as I mentioned, we can configure DRAM densities, 8 gig up to 32 gig for these, but we are flexible on those different solutions as well. And we focus around the performance needs at various card TDP levels. So as I mentioned, we have solutions all the way here from 15 watts at the total card level. That includes not only just the chip, but the DRAM and other components, as well up to 75 watts as well. And then we have a large PCIe Gen 4 out to the host. Host can be anything really for us. Our AEDK is a Snapdragon 865. We have other solutions that tie up with x86 or AMD. To us, we're agnostic, but we have a PCIe Gen 4 out to the host. And as you can see here, it's by 8 lanes. And then on our edge card, we went to a Gen 3 to meet more of the industrial requirements, temperature for outdoor deployments, but we can also support Gen 4 on that solution as well. We just optimized for Gen 3. Not specifically called out here, but we do support multi-card solutions. So we can improve performance with card-to-card communications through a PCIe switch without having to go out to the host as well. So for large networks, potential recommendation networks, this comes in really handy, and a lot of customers are using this today. Okay, so what does that performance mean? So back in March of this year, not too long ago, AMD launched their next generation EPYC Milan 7003 solution. And part of that announcement included a new Gigabyte G292Z43, if I'm not mistaken, server solution. This server solution works very, very well with our PCIe card, our half-height, half-length card, which is capable, again, of 400 TOPS, as the previous slide noted, in that form factor. This new 2U server can fit up to 16 cloud AI 100 cards, and each produce 600 TOPS. So this means, cumulatively, you can deliver 6.4 petaops, so that's 400 TOPS, 16 cards per server, 19 servers per rack, which we think is really amazing performance, and it will really unlock some exciting experiences that demonstrate how our low power processing really scales up at the server and rack level. So very, very important how it scales. So to put this in a little bit more context, kind of aligning with the previous slide, ResNet 50 as an example, this translates to more than 6 million images per second on one server rack. And this kind of AI performance, can surely enhance, extend, and scale AI experiences, through the world. So this really provides a real example how our low power processing scales at the rack and server level, and really, really appreciate the partnership with AMD and Gigabyte. So let's transition a little bit in the interest of time. I'm looking over here. I think my time is 20 minutes. So transitioning quickly over from, we talked about a little bit of hardware, a little bit of performance, and let's talk a little bit about software, which is very, very important. So this slide is really intended to provide some insight, although not comprehensive due to the time, into the functionality of what we provide from a software perspective. Our software tool chain consistently scales from the edge to the data center. It's compatible through multiple applications, from on-premise AI edge devices to large data centers. So that's very, very important. We provide very open software solutions supporting major frameworks, vendor runtimes, things like Onyx RT or Glow. We know those are vendor-specific runtimes, and we do support those. We support major frameworks natively, which I think is important, with model loaders without intermediate converters to other frameworks. So that's important as well. From a model support and optimization perspective, today, just to kind of quantify it, we support roughly 50 plus models today. They span recommendation networks, NLP, computer vision, those type of things. I mentioned too with MLPerf, but again, stress this again, we will support more models and submit more, but that's where we started with today. So we support 50 today. We'll grow and continue to grow our model zoo in the days, weeks, months, years ahead. And you'll see these models and our performance continue to flow into MLPerf, and really focusing our models on our commercial deployments and what our customers are focused on. We're providing tools for model optimization and quantization. AMET is something that we have announced publicly before. That's one example. That is our in-house open source tool. We also offer a pro version of that too for our customers. We offer additional tools for customers to optimize the models, model compilation, and the parameters. So maybe customers want to make optimizations for latency or power or accuracy, whatever they're most interested in, we do provide that today as well. And I touched upon this a little bit earlier, but again, we do support multi-card configurations to achieve best performance for very large networks that might not fit onto a single card. Again, the example we see in the market today is a lot of recommendation networks. So we split that workload across multiple cards, which I briefly touched upon earlier. From a development and deployment perspective, we support PyTorch, we support Python for development. We also run multiple models concurrently with time sharing method or model chaining. So it's taking inputs from one and feeding another model. So we do support that today. We offer end-to-end applications for computer vision, integrating video processing pipeline for AI inference. So today we're focused on doing this with our Snapdragon 865, but we'll grow and support that with other host solutions as well. And containers are very important. So we do support Docker and Kubernetes for both edge and data center applications. And then debug and monitoring. So we provide tools for customers to monitor the card's status during runtime and deployment, very important for our customers. And we provide tools to analyze the networks and performance and accuracy so customers can optimize the networks themselves. So hopefully this gives just a flavor of some of what we're doing, not comprehensive, there's a lot more, but just trying to give a flavor of how we look at the software. So this slide really kind of, I'll go quickly through this one in the interest of time, but this really walks you through how we package the functions from the prior slide into SDK software development kits. It's showing really the workflow as well, right? So the first is the app software side. That's kind of what you're seeing here in the blue box. This is really for development of the compiler work. This includes things like simulator and model tuning tools and the framework integration and those type of things as I talked about. And the second, the green box, is the platform SDK. This is really the execution of the model, the runtime, the monitoring, the tools, including debug and profiling, test tools, power stress tools, those type of things. So this is kind of gives you an idea again of how we package up these functions and how the flow works. Okay, so in summary, just to kind of wrap things up, on the last slide here. So as you heard, the Cloud AI 100 is the highest performing power efficient solution in the market today. We're very excited about the future and where we are today, how we scale from, again, edge all the way up to the data center with the similar same software tool set, same solution that we optimize for. We're very excited with significant traction today. We look forward to sharing more this year. And we're very committed to this space. We're very excited. We're going to be sharing more. We're excited the MLPerf numbers came out this week, and we're very proud of those results. Yeah, we're excited for the future. So thank you again, Linley, for this opportunity. And hopefully this provides a little bit more insight in what we're up to.
Great, thanks, John. And I appreciate you sharing those performance numbers with us today. Can you go ahead and stop sharing your screen so we can
I can
get a better look at you? So we got a lot of questions. Just a quick clarification on the production date, John. I mean, you said you've been sampling for a year. When can we expect production?
We expect commercial launches this year in 2021. So we expect commercial launches this year.
That's kind of a big window. Can you be any more specific than that?
Sure, second half of this year.
Okay.
Second half of this year, we expect. Yeah, so it takes a little bit longer, right? There has been some press, some partners have talked about working with us, right? I mentioned one here today, but there are others as well that did speak about some of the work we're doing together. But the commercial availability of our cards is right now, and we expect launches. I expect, Linley, that more the early launches will be more in what I'll call edge, right? The kind of on-premise CV plus AI type of use cases, and then more the data center launches to probably come in 2022.
Great, thanks. Yeah, the MLPerf numbers look really good. So it's good to see see those numbers there.
We took your advice. I remember I showed a ResNet 50 example to you back in early September, August, I believe it was, and you said, "Hey, I want to see MLPerf." So we took your feedback to heart.
Great, I appreciate that. Audience question though, it looks like based on those numbers, the power consumption for the dual M.2 modules has gone up, or it's significantly higher than what you were reporting as TDP.
So there's two, yeah, sorry, just to clarify. So MLPerf just started doing power numbers this cycle, right? So on the left hand of that chart, we're looking at card power numbers because not everyone submitted system level power numbers into MLPerf. It was an optional, not a requirement. So on the left hand side, we're comparing card to card power. On the right-hand side, when I focused on edge, we are aligning 100% to MLPerf system level powers. So for example, our system level power was our AI Edge development kit. That's one of the platforms that we submitted to it. And that is a total system level power. So our dual M.2 card TDP is only a component of that system level power for the edge applications.
I see. Okay. And the audience question here looks like the performance number has declined by about 25% from what Qualcomm announced earlier. Is that the
So
case?
a ResNet 50, what I told you in August, September timeframe was 25,000. Today we are over 20,000. So our submission there was a 5-card gigabyte server that achieved over 100,000 performance. And part of that is as you go into MLPerf, they have certain set of rules about what you can do with the models and pruning and quantization and those type of things. So it is a different set of rules as you submit performance into MLPerf that did degrade some of that performance. So we do stand by our 25,000 number that we shared with you back in late summer, and MLPerf did go down because of some of the rules that you need to follow through that process.
Okay. And you mentioned that the batch size of 8. So are you comparing against the competitors at their batch size of 8, or how are you?
Yeah, if you dig through the MLPerf numbers on Wednesday, what you'll see is let's take SSD ResNet 34, which I talked about. There's different batch sizes, right? So one of the things that MLPerf doesn't require is everyone to use the same batch sizes, right? So we submitted a batch size of 8, others submitted higher batch sizes. So I was just kind of calling attention to that, and there's a little bit different submissions, if you will, on batch sizes.
So you were so you're using the competitor's batch equal 8 number?
We are using the competitor, yeah. So the competitors I showed there on ResNet 34 SSD use a batch size of 32, and we use a batch size of 8 for our submission into that particular model.
Okay.
Larger batch sizes typically means better performance. And so that's an area that we'll take into account moving to our August submission.
Okay, I see. So question on has Qualcomm announced pricing for these cards?
For customers that are interested, we have shared pricing with customers. We don't publicly share pricing on our solutions, but yes, we've given pricing to customers.
Another question. So on your slide where you showed the product lineup, it looks like the DM.2 module is 3 times more TOPS than the 2E module. But on the MLPerf results, there's not that big of a difference. Why the discrepancy?
Yeah, so our dual M.2 module that you see on the product lineup was optimized for data center, right? That's why you look at it and say, hey, why do you have 32 gigs on that? Our that same module that we did use into an edge deployment, right? So we took that same model, put it into a small thermally stringent edge form factor as well, which did change the performance a little bit, and we scaled it down. So I'd say that the performance is going to vary for the deployments. So we did what we did is we took our AI Edge development kit and then used 2 different card types. We used a dual M.2 Edge card type, and then we used a dual M.2 card type as well. So so it's a little bit. I agree. I understand the question, but it's really the difference is the deployments that you put that into.
I see. Okay. And question: does the chip support floating point?
Yes.
Okay. What's the conversion rate from FP16 to N8?
It's so we support floating point 16 and 32, and so I think I had it in the slide. Let me pull it up real
Oh, is
quick.
it there? Okay.
Yeah, I talk about this in the slide. Um, yeah, so I show and in the deck, I think it's posted on your website as an example. So we talked about peak integer tops int 8. Like let's take our PCIe half height, half length card. We talked about 400 tops, and then we talked about peak floating point ops FP16. We talk about roughly half of that, so up to
Okay.
200 T flops.
Great. Okay. Thanks for
Yep.
clarifying. Um, we are running out of time. Are you going to be in a breakout session? We still have a lot of questions.
I don't think that was on the docket, but I would be happy and honored to answer any questions. So maybe we can sync up later and let me know what the best way to address any lingering questions are. I look forward to that opportunity.
Okay. Could you stay on now for a few minutes?
Um, sure.
Okay. So what I like to do then is I see there's a lot of questions here. If people would like to go to some of the other breakout sessions, you've received an email that has the links. Feel free. For those people who do have some extra questions for John, we can go ahead and just deal with them here. So I'll keep asking questions from the queue, but I would like to thank John, and if anybody wants to go ahead and go into the other breakout sessions, they are now open, so you can feel free to do that. So thanks everybody, and then John, if you don't mind, I'll just
Yeah,
ask a few more questions for the
absolutely.
people that are still interested. Um, so do you have any deployments with Super 7 hyperscale vendors? I obviously probably can't name any names, but
Yeah,
can
I
you
would
give
say
us a hint there as to whether that's coming?
I'll get in trouble for my marketing and PR folks, but yeah, no, I think we're getting strong interest. I'll put it that way, and we look forward to announcements in the future. That's about how I'd leave that.
Okay. And then on the edge side, I mean, you talked at the beginning about that there's a lot of interest in edge server deployments, and big market forecasts. But I guess what have you seen any deployments? I mean, not just your chip, but in general of kind of this edge server concept, and where is it being deployed? How's it being rolled out just today?
Sure. Yeah. Okay. So I would edge is kind of a nebulous term. I think everyone's got their own definition of edge. But one of the things I've talked about, just to kind of clarify, is really edge, kind of on-premise edge gateways, really, right? And these can be on I don't know, light poles in a manufacturing line, in a retail or deployment. And this is an area that really we're seeing tremendous traction on in particular. And this is where things like our dual M.2 card fits in very, very nicely. So I would say, stay tuned. Those will be our early announcements in that area. But when I talked about edge here, just to double click on that comment, I'm talking more about these on-premise edge gateways, I generically call it, right? And that's what our AEDK is all about, which, as you know, we've talked about in the past. It's real, and it's taking when you need to make on-premise, on-site decision making, if you will, right? And you don't want to send up that stream into a larger data center where latency matters or it's expensive to do. Although we love 5G and we have a 5G solution, obviously that works for that. That's an area that we're seeing a lot of interest on and a lot of traction.
Mhm. Can you comment on leakage versus dynamic power for your chips?
I can, but I'm not going to get into that today about comparing leakage versus dynamic power. Probably outside the scope of today's presentation.
Can you comment on the cache organization? Does it need explicit software data placement in the SRAM, or is there coherence that does this for the programmers?
Yeah, so each AI hardware block, as I've mentioned, has a lot of tightly coupled cache memory. So we talked about 9 megabyte per block of what we call a VTCM. And so each of those is dynamic, right? So you can, customers can, contain their models within the SRAM. Back to Edge, we do see some customers coming to us and saying, I don't need, any DRAM right on top that can contain my model into the SRAM, their large SRAM. So we're very flexible from that perspective of whatever the customers are looking to do, and being very dynamic.
Okay. And is it a cache, or is it just like scratchpad SRAM?
It's a cache.
Okay.
Yeah.
So, and is there a RISC-V or ARM CPU on the chip?
There is not. There is not. No, we have a very small ARM core in the chip that just more or less kind of manages the overall chip. But no RISC-V in this.
Is Qualcomm selling chips or just the modules?
We sell the modules, yeah. So we sell those 3 different flavors of the cards, right? So we do not sell the chip in this case. So it's got the full card with the DRAM, the PMIC, the processor and whatnot. So that's what we are selling, and really we don't see a need or any really interest, to be honest with you, about selling individual chips. So the market we've been in for a few years now, we're finding we're definitely finding that we have the sweet spot there.
Mm-hmm. Does the product support Keras in the software stack?
I have to get back to you on that. I don't know off the top of my head. I'd have to get back to you on that question.
All right. So it's you talked about the software in the software stack that you support a range of models, recommender models, NLP, computer vision. The MLPerf numbers only show the ResNet computer vision side. Is there a reason why you didn't submit some of the other MLPerf?
Yeah, I think, for us, it's the first time we've done this, right? And for us, I wanted to, it's a great question because I made the decision, so I got to justify the decision. So from my perspective, I wanted to go in with what our customers are looking for today, right? So those particular models are what we're seeing a lot of traction and interest on. And B, we wanted to make sure that we had obviously a viable, good submission, right, first and foremost. And we wanted to show it on multiple platforms. The good thing about MLPerf is the next one's right around the corner. We're already planning the next one. That submission is due in middle of August. And what you will see moving forward, you will see an NLP submission from us, and you will see a recommendation submission from us as well. So the way I look at this, Linley, is we're building the foundation. We want to get credible evidence out there, credible platforms, credible models, and we'll continue to build on this momentum.
Okay, great. Well, I do want to move on so we can get people off to our other breakout sessions. So
thank you.
Thanks for spending a little extra time with us, John.
Of course. Appreciate the opportunity. We look forward to sharing more. Thanks again for the opportunity.